The hidden side of the moon, also known as the lunar hemisphere that is never visible from Earth, has always held a particular fascination for humanity. This interest is not just emotional or poetic, but also scientific. For astronomers, it represents a location of great interest, as it could be an ideal site for the construction of advanced telescopes. But what are the real advantages of placing observation instruments there? And how feasible is this project? Let's explore these questions. The hidden side of the moon is so called because it is never visible from Earth. This is due to a phenomenon known as synchronous rotation, where the moon takes the same amount of time to rotate on its axis as it does to orbit our planet. In other words, it always shows the same face to Earth. However, it's important to clarify a common misconception. People often mistakenly refer to it as the dark side of the moon, perhaps influenced by Pink Floyd's iconic album. In reality, there is no permanently dark side. The moon, like Earth, is illuminated by the sun on both hemispheres, just at different times. But what makes the far side of the moon so interesting for astronomers? The answer lies primarily in the absence of interference. From the hidden side, Earth is never visible, which means no reflected light from our planet reaches it, nor, more importantly, the radio interference produced by our technological activities. Radio signals from phones, satellites, and other modern technologies create a sort of background noise that can severely disrupt astronomical observations, especially those involving very faint signals, such as those from deep space. Another advantage of the far side is the absence of the ionosphere, the layer of our atmosphere that can interfere with the reception of longer radio waves. This makes it an ideal place for a radio telescope, especially useful for exploring mysterious phases of the universe's history. One example is the observation of the so-called Dark Ages, a period between the formation of the first hydrogen atoms, about 400,000 years after the Big Bang, and the ignition of the first stars. During this time, hydrogen clouds emitted radio waves at 21 centimeters, an extremely faint but crucial signal for understanding how the first galaxies and stars formed. The absence of an atmosphere on the moon also eliminates the problem of atmospheric seeing, which on Earth distorts images. Although we have advanced technologies to correct this phenomenon in ground-based telescopes, not having to deal with this obstacle would make lunar observations much sharper and more precise. This applies not only to radio astronomy, but also to optical and infrared astronomy, making the moon an ideal observation point for studying distant objects like galaxies, exoplanets, and even the atmospheric composition of other worlds, potentially searching for signs of life. Moreover, the moon's seismic stability is another advantage. Here on Earth, gravitational wave detectors must contend with seismic noise and other interferences, while the lunar surface, being geologically much calmer, would allow for the construction of even more sensitive instruments. However, building a telescope on the moon comes with challenges. First of all, the far side has no direct contact with Earth, meaning a network of satellites would be needed to transmit the collected data. Additionally, the growing increase in human activity in space, including colonization projects and commercial explorations, could compromise this quiet, interference-free environment. This is why there is talk of far side protection, a concept calling for international regulation to protect the far side of the moon from unwanted emissions. Despite the difficulties, several projects are looking to the moon as a new frontier for astronomical observation. Among them is the Lunar Crater Radio Telescope, which envisions using the moon's natural craters as giant parabolic dishes for a radio telescope. Other projects, such as the Farside Array, aim for a network of smaller telescopes arranged on the lunar surface to create a virtual radio telescope. Though futuristic, these projects are not science fiction and could become reality in the coming decades. In conclusion, the idea of building telescopes on the far side of the moon is not just a distant dream, but a concrete possibility that could revolutionize the way we observe the universe. Returning to the moon, therefore, wouldn't just be a matter of exploration or prestige, but a fundamental step toward new scientific discoveries. Thanks for watching. Don't forget to like and subscribe to the channel to support us.